Into this video, I'm going to show you how to implement a data structure. I've received multiple questions about programmers who are struggling with, in one way or another, with the algorithm and data structure classes. And from my experience, I found that students struggle with data structure class in the same way that they are struggling with math class. They think that just by looking at an algorithm or a data structure, they will get it. So they think the way to study is to understand by looking at it, and it's not really like that. It's also a worse problem since than math class, since the student usually have to implement the stuff using a low-level programming language, which is hard for some of the students. So the logical thing that happens is that they mix the programming problem with the data structure problem, and then they all are lost and they don't know what's happening, and that's usually where they say I can't understand data structure class. In this video I will show you what is my method to implement a data structure, and how I make sure that I really understand how it works enough that I can implement it. So I will go through the theory and then I will implement the data structure with C++. So my process looks kind of like this. The first step is to understand the component of the data structure. So you have to have a good understanding about what's happening. So you have to open your notes, whatever, pick one data structure that you're studying and really get to all the detail of it and understand every part of it. So for instance, if you're looking at the linked list, what's a list, what's a node, what is the pointer that is pointing to other things, what are all the little components in the data structure. The next thing you have to do is understand what I call the movement of the component. So a data structure is never like static, it has some movement. So how is the information flowing in the thing? For example, in a single linked list, you go from the start to the end. So yeah, you really have to understand how the data structure moves. For instance, just to illustrate this point, an array, you can index directly in the middle, so you can like move straight up here. Linked list, if you want to index in the middle, you have to kind of flow through each of the nodes. So this is what I mean by movement. You have to get the right flow in your head. For instance, a tree, usually you start at the top and then you trickle down at the bottom. I think this is an important part to really understand the data structure. Next step is to understand what the data structure can and cannot do. So if we go back to the linked list example, you cannot go straight in the middle. That's impossible. You cannot index there directly. While an array you can, right? You cannot just pop one thing in the middle of the array and expect it to the data structure to be okay. You have to do other manipulation to maintain the integrity. While in linked list, you can just pop the thing in the middle and then you just fix it directly, and it will not be critical. So there's stuff that you can and cannot do, and you have to make sure that you get them down. So can I add? Can I remove? How do I update? These kind of things. And then you have to write in your own word what the data structure can do, right? So you have to really internalize the theory. And if you looked at my point here, we're not even implementing anything yet. We're just writing stuff down, making diagram on paper. You shouldn't be trying to code the data structure until you fully understand every component, how they move, what they can and cannot do. And that you really understood it enough so that you can explain it, because when you're going to get to the implementation, you need to be right, otherwise you're going to mess up. And finally, when you got that plan down, you implement this data structure following the plan, and then it will be easy because you know what you need, what component you need, what manipulation need to be done, and you can really it's easy afterward to find out where you did a mistake, so you can have some tests in there. So let's jump into an implementation. We're going to take something super simple. It's going to be a circular linked list, so it's not like a linked list. It has some twist to it, just so that's not boring. But we're going to implement this and we're going to follow the full procedure. Okay, so here we are. So the first step is to kind of get a plan of what the data structure is. You cannot just like in your head know what this data structure that you're trying to implement is doing. So you have to have a solid plan. So look at your notes, find it online, whatever, but you have to have a plan. So this one was good. Perfect. So you get to something like this, and then they're gonna explain some stuff to you. So you have to understand every component. So we're gonna try to implement this thing, the circular linked list. So we're gonna implement the singly linked list as circular. We're gonna do that. So if you look here, you have something here which is the head. It's pointing to something else which seems to be the circular linked list. You have stuff that are called node. So I get what a node is. If you just took this one in isolation like this, and a node has a data item in it and a next. And next, what it is, it seems to be the same thing as the head, which seems to be a pointer. Since we're in C++, that makes sense. So this is a pointer to the next thing, and then the next thing is also a node, and the next thing is also a node. So the first one is pointing to the next one, and the last one is pointing to the first one. So this is why it's circular. So there's no in a regular linked list, this one will point to null. So that makes total sense. Perfect. And the head is not really a node. The head is just a pointer to this. So otherwise, if this was not pointing to that, it will just not. You will have no way, you as a programmer, to access this. So from this, all the component that I need to understand is the node. What is the data item? What should I put there? The next, which is a pointer, and then the linked list as a whole, right? And this thing they call head. I understand all of them, so now I know, right? I know I'm gonna have to implement like 4 things. Now the movement, right? This is where you have to take a look at it and try to think about what should happen in all cases, right? So the movement of the information for me is like you go from the start and it goes like this and then go back here like that, right? What happens if I cut it here? Well, it needs to flow like this. So if I cut it at the node over here, the middle one, I will need to stitch this one back to this one and just forget about this one. So that's how I can keep the movement. What happens if I have 0 node, right? Is it still a circular linked list? If I have 0 node, this needs to point to null. If I have 1 node, what happens? This one will be here, and the head will point to it, and the next will point to itself. I think that's true. I think this needs to point to itself. So the node will point to itself. Yeah, makes sense. So you're just gonna iterate like this. If you have 2, the next of the first one need to point to the next one, and this one, the last one, will point to the first one. So that's the idea. If you look at the basic operation that you can have, you have insert, so you can put it anywhere. No, you can insert an element at the start of the list, so you can put it at the beginning here, so you can have to change some stuff. You can delete an element from the start of the list, so you can delete over here. You can display. This is not really a good one because you can do much more. You can, yes, insert, delete, and display, but you can also delete an index. So you can delete here, the middle. You can insert whatever. So here, for the insertion, you should technically be able to do it anywhere. So that's the main idea. So if I were to write this whole thing into my own word, I would say there's like some circle thing which has some data in it, and then this thing has a link to another round thing which is a node, and those are all stitched together by this thing that we call a pointer. And the last one, instead of dangling, it will wrap up to the first one. So I'm gonna get this circle kind of thing. To not lose that circular thing, that linked list, I need to hold it with the pointer in the main. I will need to do that, otherwise it will just fall and I will have no way of finding where it is in memory if I'm implementing it in C++. So this is for my whole idea. The insertion should happen anywhere, so I should give an index and be able to iterate through it and just find where to put the thing. The deletion should happen anywhere. I should be able to follow it and just delete the thing and then stitch it back together. And the display should just iterate through the whole thing until you hit back at the beginning and then print it out, all the data. When I insert, what will happen? If I insert the node, this is the part where you have to like really dig all the edge cases, because otherwise you're gonna get mixed up when you're gonna write it. If I insert something, like what should I change? So if, let's say, there's a fourth node I want to insert over here, what need to happen if it's at the end? I will need to make this point to this new node and then new node point to the beginning. That's it. So the index where I'm going to put it will let me know what manipulation I have to do. If I put the node at the beginning, I will have to link this to the first one and then return the node as the head. Otherwise this will point to that, right? So there's some change I need to do over here. And so this was the first and this is the last. Now what happened in the middle of all of this? If I add a node in between those two, just over here, I will need to take this next, point it here, and take this other next and point it there. And everything else will not be changed. And let's say I want to add it here now, I will have to iterate like this and follow those pointers until I hit the right index. So that's it for the adding. If I want to delete, let's say the first node, it's simple. I just remove it and then return the other node. And no, it's not easy actually. I have to remove it and then go to the last one and make it point to the first, the new first, and then return this new first as the head. So that will be the movement I need. If I delete the last one, I will have to go through each of them and then slash this one, remove it, and make the one previously point to the first. That's the idea. And if I remove the middle one, it's a bit easier because I just need to take the node before and make it point to the node after. That's it. So I think I've got every point. So let's try to actually develop it in C++. Okay, so here we are. The very first step, when you're gonna write something, a data structure, you should like put out all your components in there, right? No matter how they will interact with each other. And this is the first step of your plan. So we have a node. We know that a node has a data and a pointer to the next thing. The data could be anything, and here I'm just saying it's an int. Maybe after that we could refactor it to include any possible data type, but here it's just an int. Then we have an x, and here we have constructor. We have one constructor which accepts the data and one constructor which accepts absolutely nothing, so it will set nothing in there. And that's the two constructors over here. Those are my constructors. This is my destructor. And here is just like some C++ stuff. There's nothing hard about it, but you just need to know the language to execute your plan, because you already have a plan in your head. Good. And here, this is my circular linked list. What you have really is nothing fancy. You have a head, which is that thing, right? That's what you have. And actually no, this pointer is the head, which is pointing to here. And then you have your constructor, your destructor. So when you construct it at the beginning, you have nothing in it. You can do something fancy if you want, but at the beginning it just doesn't do anything. and then it will create an empty node with nothing in it. And then you have the three manipulation you can do. Insert node, so you insert the node at an index, delete node at this index, and then you display, and they are empty. So that's all there is to do at first. You just lay it out, make sure that the basic is there at least. Okay, so let's take a look. I've did a few changes over here. I've added a tail and a length. What I did that is because that thing, looping back to the beginning, is actually really important, and I don't want to have to go through the whole thing to be able to write it up properly. So I need that, and the length greatly simplify the code because you don't have to do some error checking every time. So we just need to make sure that those are good. Is that? So when we initialize the head, the tail are null, and the length is 0. So we have nothing in that linked list. And then let's look at insert node. So insert node, take a node and an index, and the first thing you do is some error checking. So you check the case where the index is bigger than the length of the list, and you do nothing, you just return. So at this point, we know that the insertion will take place, right? Because the index is smaller than the length or equal to the length of the list, so that will work. The first thing you have to get out of the way is the index at 0, because that's what I was saying by movement. There is some weird movement that will happen here. So if the index is at 0, you're gonna have to put it here and then just rewrite those stuff and rewrite the end of it. So when the index is at 0 and the head is completely null, you get something like this. So this is actually more complicated than I need to, because the head is nothing and the tail is also nothing. So what you do is you set the head and the tail to be the node, and then you wire up the head to be equal to the next and the tail equal to the next, so they both point to each other, but you have one thing. So you actually don't need to do all of this, you could just do that. That would still work. So you just make it wire up to itself. That's all you need. And increase the length. So this is if there was nothing at all. If there was something in it, so the index is at 0, but there's something in the list, so maybe there's a million item over here. It's simple. The node need to point to the next. So you take your blob and you point it over here. So the node need to point to the head. Sorry. Yeah, the node at next need to point to the head, and then the head need to be the node now that you're adding. And the last thing you need to do is, instead of having this point here when you have start over here, you have to point it all the way over here. So this is why we need to have a tail pointer. So you point it to the head and you increase the length. You see here we're repeating stuff a lot. We actually need to do this because we know that nothing will fail here. Good. So that's for the case of 0. What happens if the case is the length? So the index is at the length. So we're here. We're past the last index. So we need to rewire the tail. That's what need to happen. You put your blob over here. You make the next point to there, and you make the new tail point to the head. It's pretty straightforward. So the tail tail at next will be the node. The node next will be the head, and now the tail is the node. And you increase the length. We always did that. So this one is easy. So you see I separated into start, and so I have my H cases down, and then I know that whatever happened here will be stuff in the middle, right? So nothing is weird here. So I don't have to make some weird if statement. So now I just need to iterate until I hit the index in the middle that I need. So this is what I'm using. I'm using the current node and the previous node, and I have my current index over here, and I'm just going to churn to it until my current index increase enough but the idea is to keep track of the previous node and the current node. So you move them like this, and then when the index is just right, you know that you have to put the thing in between those two so that you make the right thing. So if you have the right previous node and the right current node, what happen is, let's say I want to put it here, right? This will be my previous node, this will be my current node, and I'm going to point this one to this one to that. I don't have to change anything in the head and the tail. And that's what we're doing. Previous node is that next is equal to node that next is equal to the current node, and we increment. That's pretty much it. And this is for display. So display is simple. You start at the head and you're gonna increment until you went through the whole list, and the only thing you do is you print the current index and the data, and then you're just gonna take the next node and then take the next node and take the next node. So let's test our stuff. So this is my first node, second node, third node. Just you see that. I'm gonna add them at 0, 1, and 3. 0, 1, and 2 actually. Okay, I'm back. We had some problem because of the refactoring I did. The length should not be set before the end, otherwise it's all gonna mess up everything. So we have to put them over there multiple times. That's just how it is. So if we do that for the last part, this one will be set at the beginning. So we have 14, 12, 13. So the insertion seems to be working properly. If we always insert at the beginning, we should get a reversed list. Yeah, so everything seems to be working for the insertion. So let's take a look at the deletion. Okay, so last step was to do the delete. Had some trouble with it, but I managed. So this is the insert, and this is the part where we display, and over here this is the delete. So we do the thing as right. So we do the insert, and we do them in reverse. So we have this, and then we do the delete. If we look at the delete, it has the same structure as the thing before the insert. So if the length is smaller or equal than the index, we return. Here we were smaller than before. Here, if it's equal, it means that we want to delete something that is outside of the bound, so it's not legal for us. So we just return. Here, this is the case where index is at 0. So either two things can happen. This is why thinking in edge cases help, because then you can take a lot of stuff out of the way, and then you focus at the end on the thing that is more general. So the first edge case is that you want to delete at the middle, at the beginning, and either there is one thing there, or there's one thing there and it's the only thing that exists, or there's one thing there and there's multiple things that exist, one or many. So if it's only one thing, you just scrap everything. You just restart the whole thing. If there is something there, but there may be a million stuff afterward, you have to set the head, this head, to be the head, the next item after this head, and then the tail, that next, will be the new head, so this one, right? And then you decrement the length and you're good. So what the movement look like is, I want to delete that guy, so I'm gonna make that guy be this, and then this one, instead of pointing here, will point there. So then this one is just completely, we disable this link, we disable this link. No, we disable this link and we disable this link, so it's just dangling there. Perfect, so that was this. After that, there's also the edge case when you're at the end, but we need to iterate, because to remove the stuff at the end, this one, we need the previous one, otherwise it doesn't work, right? And it's not a doubly linked list, it's a one-way linked list. So if you want to get to the end, you're gonna have to painfully go over here just to get the one before the end. That's the drawback of linked list, but doesn't matter. So either way, we're gonna have to iterate. So this is what we're doing, same thing as before. This is the iteration step. And over here, this is where we're gonna delete the last node if we need to. So if the current index equal the length minus 1, right? This is where we know we're gonna delete the last one. And what we do is we set the previous node at the current node is equal to the tail. So the previous node need to be the tail, and the tail next need to be the head. And then we decrement the counter. That's it. Otherwise, for all other cases in the middle, you do previous node for the next one equal to the current node at the next one. That's it. So you're like, let's not draw in here. Like here, this is the previous node, this is the current node. You set the previous node next to be current node next, so this one. So you just jump over. That's it. So that's how you implement, well actually let's test it. So if we do this, we're deleting the first node, so we'll do deleting 14. Let's delete 2 of them. Okay, so we should delete 12, only 13 should left. Yeah, that's it. And if I delete 0 again, only 12 should stay. There we go. So we're doing good. That's how, like now, right now I implemented. There's stuff that I could change. There's stuff that I could refactor to be a bit better. But this is a circular linked list and it's working, right? So the way you do it is you really have to, like I said before, look at the component, look at what movement happened, and then just check the manipulation you can do here: insert, delete, and display. And then this is when you understand fully what happened, this is where you go and you nail one thing at a time. Yeah, you just do one little step at a time. You do the insert first, the delete afterward, finish the whole thing with the edge cases. But that's it. You really need to take your time. And during this whole process, I always come back here and then I work with this. I don't just like think in my head. I actively work outside in paper to really understand what are the edge cases and what really happened in each of the different manipulation. Alright, that's it. I hope you enjoyed today's video. If you have questions or comments, you can post them in the comment section. And have a great week.